Hey class, let's pick up where we left off with another example. This is going to be our first example with arrays, and we will do a slightly more complicated example with arrays following this one. But let's get started with doing the worst case cost for this function here. Now, notice that I did say worst case cost. I did not say find the number of steps. I want to find the worst possible number of steps that could occur. And the reason that we have to sort of frame it like that is because if we actually look at the while loop, which I will just highlight to save me from doing it again later, can do a little bit of a better job. Oh my God. I feel like this line needs to be straighter than I'm struggling. My OCD is, oh God. Okay, it's fine. There we go. That's all the internal while loop. And what we can see is we have this if statement right here. This if statement poses a problem for trying to count steps because sometimes we might go in here and get that +1, and sometimes we won't go in there and get the +1. So what we're trying to do is we're going to try and frame this in terms of, well, what's the worst possible scenario in terms of number of steps? What's the maximum number of steps that this could possibly take? Well, we have to think about, well, what would the worst case situation look like? In the worst case situation, every single element of this array would be an even number, and every single time it would go into here. Now, you could potentially do some math to figure out the on average case, where like half the time, given that 50% of numbers are even and 50% of numbers are odd, there's a 50% chance that we're going to have to go in here, given like a normally distributed data set. And we could get really mathy on you. And we're actually trying to move away from that with these videos now, right? We're trying to think more like how this affects our lives as computer scientists. So let's break into that from right here. Let's just assume we are talking about this in terms of the worst case. We have a data set that is the worst possible data set in terms of maximum number of steps, because we are going to have to run line 6 every single time that we run line 5. Line 5 keeps evaluating to true over and over and over again for every single element within this data set. So we're just going to add that false +1 so I don't forget about it. And let's just see if we can figure this out. Now, I will also just say that you should note that down here it does say that dot length and array accesses are all going to be considered O(1) operations. What that means is constant operations, or we're going to treat them as primitive operations. So they are all +1 operations. It's worth noting that because something like an array list dot size, that is not the same thing as dot length. Or perhaps you look at like a math function, that one isn't necessarily a primitive operation or even a sorting method that's built in. Sometimes it looks like a single line of code, and so we're like, oh, that's awesome, +1. But an arrays.sort would not be a +1. That method has a running time associated with it that we'd have to consider in our overall analysis. So for our situation right now, in the simplest situation, we know that an array.length is predetermined, so it is sort of available in constant time, and we know that arrays have random access, so we know that we can access random indices in constant time as well. So we don't have to consider this as anything other than just a regular random access. That line is still just +1. So in one iteration of this loop, lines 4 to 7 each run. So we end up with 4 steps. So we can go ahead and write this out. K starts at 0. It goes up to n, but not including n. So that's n-1. And we have 4 steps. Same as always, I'm just going to keep writing it all out. I don't think that that's a bad thing. We end up with 4 n-1 minus 0 plus 1. These all cancel out, minus 0. We end up with 4n. We also need to remember that line 4 has a +1 when while is false. And so lines 4 to 7 will total 4n plus 1 steps. Thankfully, this is nice and short code, because when we look at the last piece here, we just see that we have 3, pardon me, we have 3 lines of code here that each just run once when this program starts up, +1, +1, +1. This will just increase everything by 3 steps overall. So our total f of n will be 3 plus 4n plus 1, which will be equal to 4n plus 4, which I would probably end up writing like this. That is going to be our total running time for this summation of all even numbers in the worst case scenario. So I will actually write that out in total. So in the worst case scenario, f of n will require 4 times n minus 1 steps during execution. Right? That's the maximum number of steps that we might need to have solved this problem. All right, we're going to continue with this idea of worst case. We're going to move on to the next video where we're going to do something a little bit more complicated, just because the methods get bigger and there's more arithmetic to do, but it sticks with this idea of worst case and these if else statements and how we should consider them. So with that, I will say thanks so much for joining me, and I'll see you in my next video. Bye.